Hello everyone. In this video I'm going to do an example. This example. Find the area of the parallelogram determined by these two vectors u1, -1, 2 and the vector v which is 0, 3 and 2. So to solve questions like this, first let's see. So I have two vectors u and v. Any two vectors, if they're not collinear, they form a parallelogram. What you do, you draw a parallel line from the end of u to v, and another one from the end of v parallel to u. So this is the parallelogram determined by these two vectors. Then to find the area, we have to know this formula. Let me write. Area of the parallelogram is given by, you have to do cross product of u and v. So you do u cross v. But we know that cross product of two vectors in R3 is another vector. We are looking for an area. Area is a positive number. To get that positive number, we have to find length of the cross product vector. Okay? So this is what you need to know for this question. Let's then find a cross product of u and v. So u cross v. What is u cross v? So it's a vector. You have to know how to do cross product. Let me show you for this specific case. First component, so you cover the first component of u, first component of v. And then if I put these two up and down, I will get -2, 2, 3, 2. -1, 2, -1, 2. Then the second row is 3, 2. Then that's a 2 by 2 matrix. Find determinant of that. That's the first component of the cross product. Then the second component, this time you cover the second components and put the remaining components in the first row. So I have 1, 2, 1, 2. And here I have, if I cover 3, I get 0, 2. Then this is a vector. Find, this is a 2 by 2 matrix. Find its determinant. In the second component, you have to put a minus sign there. For the third component, you cover the third components of the vectors. The first row would be the remaining components of the first component, first vector, 1, -1. And the second row would be the remaining components of the second vector. This is a matrix. Find its determinant. But what do we mean by determinant of 2 by 2 matrix? So this is, you should know this. Determinant of A, B, C, D. This is a notation for this value. Multiply the diagonal elements, A times D. Multiply of diagonal elements, B times C, and then subtract. Product of diagonal minus product of off diagonal. So let's see what happens in this case. Diagonals are -1, 2, so I have -1 times 2 minus off diagonal, so 2 times 3. That's my first component. The second component, I have a negative sign. I'll keep that out. Here, diagonals are 1 times 2 minus off diagonal is 2 times 0. When I do that, then I multiply by negative. Here, the third component's diagonals are 1 times 3 minus of diagonals -1 times 0. Okay, now I found the cross product. U cross V is this vector. -1 times 2, -2, minus 6. This gives me -8. Negative times 1 times 2 is 2 minus 0. So it's 2 inside multiplied by a negative sign. This is -2. And the last component is 1 times 3 is 3 minus, this is 0. So 3 minus 0 is 3. Well, okay, that's great. I found the vector. But to find the area, I need to find the length of this vector. So I have to find length of U cross V, which now I know what is that U cross V. It's this vector. Okay, well, that's good. I have a vector, and if I find the length of that vector, that gives me the area of the parallelogram. Here, recall that the length of a vector in R3 or in Rm in general is that you square each component, you add them, and then find square root of that number. So here, the components are -8 squared plus -2 squared plus 3 squared. That gives you a number. Find the square root. Okay, so let's see. Here I have 64 plus 4 plus 9. Then you add them. You have 68 plus 9 gives me 77. So the number, the length of U cross V is equal to area that I was asked to find. So this is the area of the parallelogram. Square root of 77. Okay, just very quick wrap up. If two vectors is given in R3, they form a parallelogram. That parallelogram, the area of that parallelogram is given by this formula. You have to find U cross V, it's another vector, and then find the length of U cross V. That's the area of the parallelogram.